Hello. So this is calculus class and we'll do limit problems with trick, and there are two basic formulas we will use. So let's see that. So these are the two basic formulas we will be using. Limit theta tends to 0, sine theta over theta is equal to 1. And this is limit theta tends to 0, 1 minus cos theta is equal to 0, or it can be cos theta minus 1 over theta, that also is equal to 0. So let's do some problems. First we'll start with basic and then we'll go for most challenging problems in this concept. Okay, so this is the question given to us and we have to solve it. So we'll use this fact to solve this question. So first let's use properties of limits. So this is sine 12x, and we can use the properties of limits, and this will be x times x, and this will be 1 over sine 5x. So we know that sine theta over theta is 1. So we need to have 12x there. So what we'll do, we'll multiply and divide by 12x. So this gives 12x, and this is equal to sine 12x over 12x. And this gives sine x tends to 0, and this is 1 over 5x. So we basically will divide and multiply by 5x. Okay. So now we see we can put the 12x over 5x out. And we know if x tends to 0, then 12x will also tends to 0. So we can write more clearly over here. So this we can see that this is same as this fact. Okay, x tends to 0 means 12x also tends to 0, and this is limit. If x tends to 0, 5x also tends to 0. So this will be 5x over sine 5x. Okay. Now this x and x cancels, so this becomes 12 over 5. And this is same as this fact. So limit 12x tends to 0, sine 12x over 12x is 1, and this is also equal to 1. So the answer is 12 over 5. Okay. Now let's do the next question. So this is a question, and we can use this second fact which was used here. So this is 4x and this is cos of theta. So what we can do is we can write minus 4, okay, and limit x tends to 0, okay, and this we can write 1 minus cos 4x, okay, over 4x, okay, and we can use this. So now this is minus, and limit x tends to 0, 1 minus cos 4x over 4x. This is same as this fact. So we can, and x, when x tends to 0, 4x will also tends to 0. So this will be negative times 0, which will give 0 as the answer. Okay, let's do one more problem. So this is the question given, and it is limit x tends to 0. So if we put x as 0, sine of 0 is 0, 3 into 0 is 0, and 10 of 0 is 0. So we get 0 by 0. So let's make some changes and see if it works, and because this 0 by 0 is indeterminate form. So what we'll do is we'll divide numerator and denominator both by x. Okay, so we have divided both by x, numerator and denominator. Now let's use property of uh, limits and simplify this. Okay, so this is first we'll just use sine of x over x, and this gives 3 plus tangent x over x. Okay, so now this gives, using property of limits, this gives limit x tends to, this is like to the whole like this. So now uh, limit sine x this, and limit x tends to 0, 3 plus this. So we can further change this tangent x to sine x over cos x. So this gives limit x tends to 0. Tangent x is sine x over cos x. So this will, we can do like this, sine x over x cos x. Okay. So we can further do this as limit x tends to 0, sine x over x, and this gives limit x tends to 0, 3 plus this we can separate like can be as a product of two limits. So we will write sine x over x, and we can write limit x tends to 0, 1 over cos x. Okay, so now we can use this fact limit theta tends to 0, sine x over x is 1. Okay, so our numerator gives us 1, this gives us 3, and this is again 1, and cos of 0 is, when we substitute, cos of 0 is 1, so 1 over 1 is 1. Okay, so this gives 1 over 3 plus 1, which gives 1 over 4. Okay, so we have used here properties of limits. I'll just put a picture of it that we have used in the last class. So these are the properties of limits we used. This is for when we separated numerator and denominator here. Okay, this limit we used when here when we found out the product of this, and this this is seventh property. We used it here. Okay. So our final answer was 1 by 4. Please see to this. If you have any difficulty, please message me. Let's do a next question. So this is a question given to us, and if we put x is 0, this will give under root 2. Cos of 0 is 1, so it will give 0, and sine of 0 is 0, so this will be 0 by 0. So let's see if we can make some changes and we can solve this question. So we can, as it is 1 square root of 1 plus cos x, we can use half angle identities to simplify this. Let's see. So we know this half angle identity here. So we can use it and replace it here. So 1 plus cos x, we can write it as square root of 1 plus cos x. We can write it as under root 2 cos x by 2. And also the sine square x, we know cos square x plus sine square x is equal to 1. So we can replace sine square x by 1 minus cos square x. So after replacing this, now we can factor out square root 2. Now the denominator is in form of like a square minus b square is equal to a plus b and a minus b. So we can write 1 minus cos square x as 1 plus cos x and 1 minus cos x. Now we have got this simplified form. We did a plus b and a minus b. So is there any way when we can replace 1 minus cos x and such that 1 minus cos x by 2 can cancel off? So we can again use the half angle formula for this. So we know this half angle formula, cos x uh, is equal to cos x sin x by 2 is equal to square root of 1 minus cos x by 2. Okay, so when we simplify, we get square root 2 sin x by 2 square root of 1 minus cos x. When we square, we will get 2 sin square x by 2 is equal to 1 minus cos x. So this 1 minus cos x can be replaced by 2 sin square x by. So after we get a square minus b square like 1 plus cos x and 1 minus cos x, we see here that sin x by 2 is square root of 1 minus cos x 1 minus cos x by 2 half angle formula. So when we simplify, we will get 1 minus cos x as 2 sin square x by 2. So now we replaced 1 minus cos x, this 1 minus cos x with 2 sine square x by 2. So now since we want to simplify, we can write, we know sine square x is 1 minus cos square x. So sine square x by 2 will be 1 minus cos square x by 2. Okay, so because we are trying to simplify, so we'll see if something from numerator or denominator can be cancelled off. Now since we have put sine square x by 2 is 1 minus cos square x by 2, we can write now we can write 1 plus cos x by 2 and 1 minus cos x by 2 here. Same as a square minus b square is a plus b and a minus b. So here we wrote this as 1 plus cos x by 2 cos x minus 2. Okay. Now this and this will cancel off. Okay. So now what we are having is, now this is a simplified uh, version form we have. Now let's put x is equal to 0. So we know cos of 0 is 1 and cos of 0 by 2 here is also 1. So this is 1. So this we will get under root 2 by 2 times 2 times 2, which will give under root 2 by 8. Okay, so please go over this question and please let me know if anything is not clear. Let's do one more challenging problem. So now next question is, find the value of constant m so that function gx is continuous. So we know that any function gx can be continuous at x. Suppose the x is equal to a if the limit fx when x tends to a is same as the value of fa. Okay, I'll just write it down to be more clear. So any function which is continuous, any function fx is continuous at x is equal to a is when the limit of f of x is same as the value of the function at a. Okay, basically we do not have to lift the pan for this, it is same. So in this condition, in this question, when x tends to 0, when a is 0 here, g of x is same as g of 0. The limit is same as 0. Okay, so we'll write here. So g of 0 is m. So limit is equal to 0. Limit extends to 0 of g of x is equal to m here. So let's simplify this using, first we'll use half angle formula and simplify this. And then we'll use the facts we learned in the beginning of the class. So this is cos of 2x. So we want to simplify, we want to use the sign fact. So let's simplify this, and so this is cos square x, which can be written as 1 minus sine square, and this is sine square. So this is equal to 1 minus 2 sine square x. So let's put it and simplify this. So now on simplifying, we will get this 1 and minus 1 cancels. This gives 2 sine square x over x, and this gives equal to m. Okay. So now again we can use the formulas we used in the, so this will be equal to x tends to 0. We can take 2 out, so we are using this formula, and this is sine x over x square is equal to m. Okay, now we can use this fifth property. So this gives limit x tends to 0 sine x over x square is equal to m. Okay, So now we are using the first property we learned in the beginning of the class. This is this one. Okay, so this will be equal to 1. So substituting this as 1, and 1 square is 1, so it doesn't make difference. So we get m is equal to 2. So if m is equal to 2, then this function will be continuous. Okay. Please go over the work and let me know if anything is not clear. Let's do one more problem. So this is the question given to us, and if we put x is equal to 2, we will get tangent of 0, which is 0, and denominator is 4 minus 4, so it is 0. So we'll get 0 by 0 indeterminate. So let's simplify in a manner that if we can, and try to do that. So in this case, I converted tangent x to sine x minus 2 over cos x minus 2. Okay, and factorized x square minus 4 to x plus 2 and x minus 2. So let's simplify this and see if we can use the fact we learned. So this is simplifying the denominator. Now let's see if we can write it in a form where it uh, is in the form of the fact we have learned. So this is x minus 2. So I'll put this as x minus 2. And this is 1 over limit x tends to 2. Okay. And x plus 2. And this is 1 over limit x tends to 2 cos of x minus 2. I've used the properties we learned in the last class. So now this is limit x tends to 2, where this is x minus 2, x minus 2. This will be 1. But to explain more, I can explain you here. Suppose x minus 2 is theta. Okay. So if x tends to 2 means theta tends to 0. Okay, and this will become sine theta over theta, and theta tends to 0. Okay, this will be same as this. If I put x minus 2 as theta, and this will get a 1. Okay, so we'll put 1 here. Now in this case, we'll substitute x is equal to 2, so it will give 1 by 4. And this will be, if we substitute x is equal to 2, this will be cos of 0. So cos of 0 is 1. So we'll get 1. So our answer would be 1 by 4. Okay, so we'll do more harder problems in the next class, and we can use other laws also to solve these questions, but right now we have not learned that. So we are using this with the topics we have learned up till now. Okay, so thanks for joining, and please keep practicing.